Creo que va siendo el momento, ¿vale?, de presentar la segunda charla. Es el momento de recibir también a nuestro segundo speaker. Él viene directamente desde Google para estar aquí con todos vosotros y vosotras y él va a compartir hoy una solución clave. Hossein nos va a iluminar sobre cómo optimizar la integración de código Dart con funcionalidades nativas. En esta charla él la va a dar en inglés, ¿vale? Espero que mínimo tengáis un B1. Él va a presentar un nuevo enfoque que usa herramientas para generar código automáticamente, creando una conexión segura, rápida y con las funcionalidades nativas de cada plataforma de nuestras aplicaciones de Flutter, ¿vale? Un fuerte aplauso para Hossein Yousefi.
Gracias. Okay, so my name is Hossein Yousefi. I'm a software engineer on the Dart team, specifically Dart native interop team at Google. And this is a talk I gave in FlutterConf Berlin as well. So I'm kind of repeating that. But I'm going to make it a little bit shorter and also kind of point you to some videos after the fact so that you can kind of get to know this in kind of native interop in more detail. But here we go. So let's talk about something that we do as Flutter developers. So Flutter, as you know, is a cross-platform framework for developing applications, and so usually for the most normal circumstance, everything will just work. You write some code, it will run on iOS, it will run on Android, it will run on the web, the desktop, hopefully, right? But sometimes you hit like a new requirement, right? You want to integrate a new machine learning library. You want to support some niche piece of hardware. Or you want to, like, a brand new feature just got released on iOS or Android or some other platform, and you want to kind of use that. I was just talking to Victor today about liquid glass, right, in iOS, and multiple different features, or like the Apple Pen support for iPad, right? This new thing comes, and the Flutter applications don't immediately have access to it. So in these kind of places, what do you do first? So who here knows pop.dev?
Creo que está hablando súper bajo, no se escucha, ¿no?
Okay, so pop.dev is a website that you go to find Flutter packages. Perfect. So when you go to pop.dev, you can like search for any packages that you want to use, and then hopefully some good soul out there has created something for you. However, that's not always the case, right? In terms of like a niche piece of hardware or brand new feature, it's not always the case. So this means that you have to kind of create this communication bridge yourself between the native platform and the Dart code or the Flutter application. So I want to kind of call out not in a bad way, but I want to celebrate the heroes of our ecosystem, the Flutter and Dart ecosystem. There are these people who we call plugin authors, who go and actually write this bridge between the native platform and the Dart side, and they simplify our work. So if we want to use the device's camera, we just go up to pop.dev, we type in camera, we find some plugin that is named conveniently camera probably, and we use it, and it works. The same thing for device storage. The same thing if you want to like display a web view, right? So who here has any experience developing plugins? Okay, can we get a round of applause for them? So the work of plugin authors is complex. It involves like working with multiple platforms, different programming languages. So yeah, it's very essential for us to have them. And plugins are awesome. They basically abstract away the underlying platform differences. You don't have to kind of know that camera in iOS is done in a certain way, on Android it's done in a different way, on Mac, if you want to use the webcam, it's a different way. There is just this one interface, one plugin that you use, and then it will just work everywhere. So it also allows teams to work mostly on a single code base. Like that's one of the superpowers of Flutter to begin with. The reason that we really like Flutter is because it kind of allows everyone to be working on the same thing. We don't want to have a bunch of if statements inside our code. Oh, if it's Android, then I need to do all of this, and if it's iOS, then I need to do all of that. We want everything to kind of be neat and use the same underlying interface. It obviously shortens the time to market, and it's the backbone of the developer experience at Flutter. Now, in this talk today, I want to kind of show you a simpler way to start kind of going towards this plugin author person, but maybe introducing a new persona called the native bindings author, which is a little bit easier, is not as involved as the plugin author, but it will like support the plugin author. So native bindings author is a person who will create high fidelity type safe and maximally performant bindings between the Dart and the target language. So you can imagine if you're like creating an iOS application, what is the underlying like language for the API of iOS? It's Swift. If you're if you're developing an Android application, it's Kotlin and Java. So we want to have a way, because we are writing Flutter in Dart, to communicate between Dart and Java, communicate between Dart and Kotlin, between Dart and Swift, between Dart and C, whatever. So we have some tools, namely JNIgen for the iOS side and also the C side, so also desktop and Mac, and JNIgen for the Android side that will make this a little bit easier. So they are code gen tools that will automatically translate your code, the Java code that you want to call, to Dart. Like they will basically create bindings so that you can call them directly from Dart. Now, we go through the history of how this kind of bridge making used to be before. So before we had this thing called message channels. Who here knows about platform channels, message channels? Okay. So what message channels, platform channels used to be is that whenever you go on pop.dev and have and access this camera thing, under the hood it is actually using this system. What is this system? It's a named communication channel between Dart and the platform, and it uses message passing. So everything that we want from Dart side, we send a message to the platform side. On the platform side, we kind of look at the message and we deal with. One thing that is important that is every data on this channel is copied. So if we have something on Dart, it is going to we need to actually serialize it in order to send it. We basically make it into a binary format using this standard message codec. It's a binary codec. It is simple, it is secure, but it is asynchronous. What do I mean by that? I mean that basically it's not immediate when we want to do something in Dart. We have to kind of wait for the platform to be available. We need to serialize what we want, and then we pass it to the platform. Now this is slightly cumbersome, right? Because what we need to do, there are certain problems with this method. So the first problem is there is a performance tax. Because there is this encoding and decoding going on between Darts. So say you have a bunch of things that you want to ask your method channel, like, oh, I want the user is trying to focus the camera on this specific location, right? I need to like serialize all of that data, pass it through this method channel, asynchronously wait, and then on the platform channel kind of do the thing. So that's one of the problems. If the data that we are trying to send back and forth between the platform and the Dart side is large, then this tax is larger as well. We need to just copy more data, right? We can't just share the same memory. The second problem with this approach is the fragility tax. So all of these things are going to kind of we strip away all the typing information that you have. So in Dart, Dart is a type-safe language. It's a strongly typed. You can kind of use those to your advantage. However, when we want to cross this bridge, we need to kind of let go of all the goodies that we had before. We have to make everything dynamic. We have to make these string-based identifiers to call stuff. We basically, for example, go on the Dart side and say, oh, I want to take a picture. And on the platform side, we say, oh, if the user wants to take a picture, do this. And the take a picture thing is like a string, right? And we need to like have if statements. If the message is X, do that. If the message is Y, do this other thing, and so on and so forth. So we kind of lose that. And you can imagine if we, for example, mistype the string between the platform and the Dart, the compilers won't yell at you saying that you actually made a mistake. It will just silently go on, and then you have to kind of debug it in runtime. So you lose some of the typing information. However, if you were just in Dart, if you're calling a method in Dart, or in Java, or in Swift for that matter, if you type in the name of the function wrong, you will immediately see that you are typing it wrong, right? So you lose some of that, and that's the fragility tax. And the same goes for types, by the way. You lose the notion of the fact that the second argument for this method needed to be a double, for example. And the third one is this maintenance tax. So you have to constantly context switch between the platform side and the Dart side. You are writing your Flutter application all fine, but then you have to kind of go and open Xcode because you are writing your iOS application. You're now using Swift. You go back to Dart. You go back to Andreu Studio because you're writing some Java code. Oops. Okay. There we go. Oh.
Está haciendo cosas raras la pantalla. Está haciendo cosas raras la pantalla.
There we go. Oh.
Let's try with the speak of your direct activity.
No, que se le ha ido la
Sure.
pantalla.
Maybe a matter of the connection.
Exactly, yeah.
You never know.
Problemas técnicos.
And also the Macs also have some problems sometimes with
Yeah.
Yeah.
It doesn't mean it's going to work.
Well, okay, perfect. Thank
Es un
you.
día
Yeah.
largo.
All right. So the problem is fixed, thankfully. And so there is this context switching between the Dart code and the platform code all the time. Then it's also hard to create a unified abstraction. It's a hard thing in general to create unified abstractions. You start by kind of saying, oh, well, I want to kind of create a camera thing. And this camera thing has to be the same for iOS and Android. And Flutter supports a bunch of other stuff as well. It supports, for example, Mac and Windows. And then on Mac and Windows, you have a webcam, right? But on the iOS, you have this notion of the front camera and the back camera, right? So how do I create some sort of an API that covers all of these bases, right? It's hard. It's a hard thing in general to do. And maybe Android has some camera features, or iOS has some camera features that Android doesn't. How do I expose this API in a unified way? It's a hard problem to tackle. And then what happens if all of a sudden Android introduces 5 minutes? Introduces another thing. Then I have the API kind of breaks down, and then I have this problem of trying to then mold the API that I built in a different way. And it's like a bottleneck for adopting native platform advanced. All right, so with all that said, I quickly go over this slide. We had this thing called Pigeon that addressed one of the problems. So you can go and check this tool. It's called Pigeon. It addresses the fragility tags, but still uses message channels under the hood. So we still have the performance tags and so on. So what are we introducing? We have been working on Dart FFI. FFI stands for Foreign Function Interface, and it's a way to call any C code directly. And then there is also package JNI. What package JNI does, it leverages the foreign function interface to call C code, to call Java native interface that will then connect to Java. So that's how we kind of call Java, and with Dart FFI we call C and Objective-C, for that matter. So this will eliminate the performance tags because we can just pass pointers around. We don't have to actually serialize the data and pass it around. We can kind of work with these pointers, so to speak. Now, what about the type safety and what about the fragility tags? Writing these like FFI and JNI stuff manually is hard. So there are 2 packages, soon to be 3. SwiftGen is also in development, called FFIgen, JNIgen. FFIgen is basically for C, Objective-C. You have some Swift code, you have some Objective-C code, you just run FFIgen on that. It will create Dart bindings for you that you can call directly from Dart. The same goes for JNIgen. So no more passing messages around and like having if statements saying, oh, did I get this message? Did I get that message? In case I did get this message, do this, like open the camera. In case I got that message, like actually shoot a photo and so on. You basically have all of the functionalities that the native platform provides at your fingertips. And the same goes for JNIgen, for Android. Now, there are like specific details on like how we can kind of make this generated code more Darty, which I will skip for the sake of today's talk. But what I want to kind of go on about is let's kind of have this vision going forward with JNIgen, FFIgen. You can you can just Google JNIgen, FFIgen, or come to me after this talk, and I will provide you with like specific links if you want. But the vision I have for the ecosystem of Dart and Flutter is this. Let's make it more modular. Let's make it more collaborative. Let's have all these native bindings that we generate using FFIgen and JNIgen, maybe with a facade wrapped around them to make them more Darty, up on pub.dev. Let's just publish our work there. And this basically creates a way so that we can just write pure Dart code to build our unified API. There is no serialization. There is no like wrestling with multiple different native languages. The native bindings authors, the people who will run FFIgen, JNIgen, and maybe tweak the code a little bit, are these kind of new roles in our ecosystem that can help everyone else. And a feature that this will allow us, I talked about the fact that having unified APIs are hard. And this problem kind of remains hard, right? In general, this is a hard problem. However, this will allow us to have a mechanism that will lower, like we can scale down to a lower, more powerful layer whenever we want. What I mean by that, let's say that we have, again, in camera, set zoom is common, right? For Android, we have a camera control that set the zoom ratio. And on iOS, we also have AV capture device that set video zoom factor, right? So someone kind of creating a plugin for camera will just do, oh, well, let's have a method called setZoom that will call this one on iOS, we'll call the other one on Android, right? However, there is this specific Android thing called like set extension mode, right? Like there is extension mode.bokeh. And this thing is only like available on Android. There is no like exact match Like maybe there are like some things, but like it's hard to kind of create a unified API for everything, right? And well, let's just have like this camera X controller or whatever we have. Let's have like a whatever camera we have. Let's have like .android getter in it that will actually expose the underlying thing. And whenever we like in our code, whenever we want to actually do something specific for Android, let's just do camera.android, and that's how we kind of access the underlying object. This way, we are not like forced to try to like wrap this API around 100% of our interface. We can maybe do 80% of the commonalities, and then whenever people will need, and this will work for 80% of your use case as well, for the normal things of like just capturing a photo or whatnot, but for things that are more platform specific, we can do this. All right, so let's just jump to the end of the slides. What I want to end with is that the future of ecosystem is in your hands. So we at the Flutter and Dart team at Google are just not that many people, but you are a lot. So yeah, just build stuff with FFIgen and JNIgen and publish it to pub.dev for everyone to use. And yeah, be a native bindings author. Hopefully everything, once you do that, then most things will just be a pub add away. And we don't, like, most people don't have to do this, even right now, but we can do better. So thank you. And let's have some questions, one or two.
I want to ask you, I really love Flutter because of the abstraction it provides. So when I want to create a new project, if I already know I'm going to use a very specific API or capability like AI interaction, and I'm doing an iOS application, for example, I probably will go native from the beginning. So I want to ask you, this is kind of related to your talk, what would be your criteria for still developing Flutter application and also going to the native part of it? How is that? Do you understand that?
Yeah.
Thank you.
Okay, so I can answer this in a. So like the question is, if you want to like write an iOS application and only an iOS application, then you can do a native code, and that's fine. I would personally just write probably native. I wouldn't do Flutter because it's like you're only writing an iOS application. It's fine. Maybe you have some Flutter experience, so that can dictate. Maybe like you have more experience in Flutter, so it's easier for you. So for that reason, yes. But otherwise, if you're just doing iOS, then it makes sense to just do iOS. What I'm talking about is that you are trying to do a bunch of things, but then you hit these corners where you actually want to interact with the platform as well. And the good thing about Flutter is everything is native anyways. So you have access to the entire platform. Like every Flutter application is a native application. So technically, you can do Swift UI in a different page in your Flutter application. And that's fine if you want to. And this allows you to share more of the code. So if you have now Android and iOS, and for 90% of your code you used a Flutter, and then you have like 3 screens that are like iOS specific, then you can just like write Swift UI and like use that to happen and so on. So it's about sharing more code. It's about being more productive. Does that answer your question? We can talk later in more depth. So one more question.
Actually, that was in Flutter before the new FFIgen the code of the native meeting is running another thread. But right now, if we code everything in Dart, then this will be only run in one thread that Flutter use. So it's better than run in different threads, but with the cost of the serialization connection between them, or is better than run only that thread and not the code there?
Okay, so the question was, is it better, what it used to be, by the way, that the threads are merging. There is a video that Craig made on Flutter YouTube channel, I think, that you can go and watch that's about the thread merging. But the question is, with the previous way of doing Flutter plugin development, there used to be two threads. One platform thread, one UI thread. UI thread would send these messages to the platform thread. Platform thread would just handle them. But there was this serialization, but now there is just one thread, in this new way. It's actually not entirely the case, right? Here what we are doing is that we are giving you the option to go to the different thread. Before, you didn't have the option to be on the same thread. So now you are on the same thread, and then you can create a new isolate, and then be on the different thread. So you can always go to the other one. And by the way, you still don't have serialization. So you can just create a new isolate, run your code on that isolate, don't pay the serialization tax, and still be on a different thread if you so choose to. So it's kind of the best of both worlds. It basically enables something that wasn't enabled before. And it's also the fact that if you have a block of different synchronous operations that you want to do asynchronously, you can also do that. So before, you can imagine if you do if you want to do I want to do set zoom and I want to take a photo and I want to do this third thing, there are three different asynchronous communications, right? But here you can do, let's create an isolate, so one asynchronous operation, and then within the isolate, let's do these three all together. So it's less round trips, right? And these three are within the platform, so you want to do them synchronously next to one another. So it kind of enables more use cases. But I'm happy to talk more about in detail after the time. All right, so thank you all. I have to stop taking more questions, but meet me after somewhere and
Big applause for Hossein.
Thank you.
Good one, so every person has 90 questions. The person that, thank you.